Previously, we have defined average velocity being the change in position or displacement divided by the time taken. We watched the video of Usain Bolt running at the World Championships in Berlin in 2009, where he broke the world record for the 100-meter sprint. We can plot Usain's displacement as a function of time, and it might look something like this graph, where he starts off slow, then speeds up before slowing down again after passing the finishing line. The instantaneous velocity at any point in time is equal to the rate of change of the displacement time curve, or its gradient at that point. Thus, Usain's change in velocity is indicated by the change in the gradient of the line from a small gradient at the start of the race to a high gradient during the race and then a smaller gradient again after the race. This change in velocity is called acceleration. Average acceleration is defined as a change in velocity divided by the change in time. Since velocity has a unit of meters per second, time has a unit of seconds, and acceleration is velocity divided by time, then the unit for acceleration is meters per second divided by seconds, or meters per second squared. And just like we defined instantaneous velocity as a rate of change of displacement with respect to time, we can also define instantaneous acceleration as a rate of change of velocity with respect to time. Since velocity is a vector and acceleration is derived from velocity, then it follows that acceleration is also a vector. Thus, acceleration must be described in terms of its quantity or the magnitude of the acceleration as well as its direction. If the velocity is increasing, the acceleration is positive and the direction of acceleration is the same as the direction of change in velocity. If the velocity is decreasing, then acceleration is negative. Negative acceleration is also called deceleration. Consider an object whose motion is described by the following displacement graph. The plot of its velocity is shown in the graph below this. Which of these four acceleration graphs best describe the acceleration of the object? Consider the motion of an object which is described by the following graph. What is the acceleration of the object at 4 seconds? In summary, acceleration is defined as a change in velocity divided by the time taken to make that change. It has a unit of meters per second squared. Acceleration is a vector and requires both the magnitude and direction to describe it. Positive acceleration results in an increase in velocity, while negative acceleration or deceleration results in a decrease in velocity.